So thank you very much, Anik, for inviting me. And when we discussed together, I mean, we didn't think, to be honest, but most of what you said, we are really aligned. And the goal for this presentation was about two main things, let's say. The first one is, what is the impact of AI at scale? And the reason we are asking this question is that most of organizations, and you said it, are, let's say, past experimentation, but not yet really at scale or industrialization. We see a lot of pilots, a smaller number of production use cases, and even a smaller, let's say, set that are really industrialized across the enterprise and companies. And adoption also depends on the different functions we have in the company. So typically, customer services or IT operation, they move faster. And when you look at the core operations or regulated processes, they move a little bit slower. And it's just normal because it's harder and the risk is higher. And also what we see is that people that really industrialize AI and are kind of gaining ROI and things like that is because they change their operating model. It's not only about technology itself. If we use AI as a tech add-on, it can work for a specific use case, but it's not a real and profound change in the company. And also the reason for that is we see a lot of hype regarding AI. Some people call it bubble. I'll let you judge about it. I prefer to speak about hype, but clearly there is a kind of a gap between what is expected from AI and the reality of AI. And when you look at the hype, they assume things like clean data is ready. When you train a model, you use the internet data. And as you can imagine, when you look at the internet data, I don't think we can say that it's a clean data set, right? There is also, they assume also that the risk and compliance is an option. So when you work with regulated industries, I think it's not an option. And models are accurate enough by default. We can see that when you deploy it in a real and enterprise workflow, maybe it's not really the reality. People will adopt it very instantly. Yes, it's easy to prompt, but I will give you a couple of examples where prompt can be problematic and that you can gain a return of investment that will show up in weeks. And then you look at the implementation reality. And implementation reality is that, yes, data and process quality really determine the outcomes. And the data, we are not speaking only about the internet data, but your own data, company data, the enterprise data. Then we speak about things that are not really sexy: security, IP, privacy, auditability, things that are not shiny for the hype, but are really important to companies. And then we need also guardrails. And when I say guardrails, is keeping the human in the loop, as simple as that. Who takes the decision? Is the human in control? And evaluations of the models, monitoring of the models. So many questions that are coming. Change management is half of the work, and return of investment comes really by redesigning the workflows, and I will give you an example. And then second part, let's say, it's to look at the future, where is coming in terms of research, because many things will evolve, and I think it's important to have a view on that one. So what is the impact of AI? And the first thing I wanted to say is when OpenAI released ChatGPT, we have seen a real momentum regarding AI, but a lot of, let's say, people in the AI space, scientists, you were part of it, Anik. At the beginning, we said, with small models, you can have very good performance, very good return of investment, because they are consuming less energy, They are consuming less GPUs. They are also lower in terms of costs. And when you train a specific and small model on a specific task, you will really get some insights. And since a couple of years now, we are seeing that. So it's a matter of fact. We see a rapid progress in the capability of small language models, as you can see in the figure. And the improvements are due to data quality and pre-training recipes that also evolved, and also novel, highly efficient model architecture. So you see the increase in terms of performance of the for example, the open source models. But believe me, when you train, for example, when you take a small open source model and you train it for a specific use case with the enterprise data and so on, you will get a return of invest. And you can see also what we call the intelligence per watt for local LLMs. So local LLMs means basically that you run it on hardware inside your company, on-prem, as we said, or in your computer also. And we see that a large fraction of useful requests do not require frontier capabilities. So it's normal that the hype is pushing to consume large models, because consuming large models means consuming a lot of cloud. So that's also one of the reasons. But we have today powerful local accelerators, and yes, we are seeing a redistribution of AI inference workload across the computing landscape. And we see that these improvements not only from model advances, but also from the hardware side. We have been working on that, and yes, we work with small models that can run on a single entry level GPU. We can work on micro and tiny models, and also nano models, because when you run this kind of workloads on edge computing, for example, you need really light models, but I will give you some examples. And one of the first things is, when you work on this kind of projects, we have to, let's say, lead by example. And leading by example is also to eat our own cooking. So you develop AI, so let's apply AI to our own processes and workflows, and this is what we did inside the company. And today, 70% of our workflows have AI somewhere. It's not, sometimes it can be 100%, sometimes less, but there is 70% of our workflows that are using AI. But the journey didn't start with a tech add-on. The journey started by eliminating what is not necessary in the company. So sometimes you have a process or a workflow that is using like dozens of applications. And the first question we ask is, how do we eliminate what is not needed at all? Or at least we consolidate and do this first step, let's say, on the automatization process. Then we simplify. So long journey also, we worked on simplifying our workflows and processes and so on to really, let's say, have something very simple that then we can automate. And when I say automate, we'll give you some concrete examples, but it's a 5 years project. And we started to gain in terms of productivity 3.5 billion at the company level. And this money, it's also a way for us to reinvest in R&D and also acquisition. And we did, since this program, like more than 50 acquisitions. So it's a flywheel for growth, we call it like this, but it really works. And when you deep dive a little bit on the workflows, I can give you one example with HR. HR is a good example because when you are IBM and you have a lot of people, we used to have HR at the global level. We used to have HR at Europe and Middle East Africa, for example, then within the markets, then within each business unit, and so on. And we decide to automate most of the HR workflow. And what happened concretely is that most of the questions and requests that are asked by IBM employees, 94% of them are addressed by AI, which means it's not only I'm asking a question. Yes, it is also, but it's also putting something in production within the process. Typically, I'm a manager. I give an increase of salary to an IBMer. Then I can interact in natural language and put this into the process and in production. So the idea is not only chatting, is have a single interface where you can chat, but then all the workflow is automated. So basically, it's hard, but 70% savings in HR project, in HR budget, which means a lot of things, but it means also that maybe we'll not hire in the support functions as we hired in the past. So that's one of the consequence. On the other hand, we hire people that have more direct roles like sales, technical people, research, and so on. And we do the same with the customer support, for example. So imagine we have many products and we have the customer support function, roughly 26,000 people, and they are answering the questions of our customers and partners every day. And we were able to automate partially this process. I'm saying partially because 70% of the questions are answered by AI, which is a big deal already. But then when we are not able, when AI is not able to answer the question, we go through another level. And here you have people that are dedicated, augmented by AI to answer the hard questions of the client. And this is what they are expecting from us. The scary thing is that when you put an AI to deal with external people, so our clients, you can be a little bit afraid because maybe it will be wrong or things like that. But we measure the what we call the net promoter score, and this one increased by 25 points. So it's all kind of examples that we measure in order to be sure that what we deploy is valuable. And then, of course, we do this in the IT space, but not only. But IBM is an IT company, but believe me, 5 years ago, we had a couple of challenges like our clients to control our costs. For example, we have plenty of hardware in many places. So when you have to update or deploy a patch or an update or something like this, it can take time. It could take some months about it. And we resolved this problem. And now, I mean, we have like, I can give some numbers, but 35,000 automated resourcing actions per month. We decreased the number of CPU requests. We did savings. We reduced the cycle time for business to see monthly financial results. And in fact, AI helped, but what it really did, it's that it make it transparent for everybody what we have, what is running, what is the cost of this, all these runs and the cost and the expense and so on. So we make it transparent. And by the way, when you have to update something or you have to deploy or have to do a configuration, 70% of the code is generated by an AI. So this is the kind of examples I give, but they clearly for us it was fundamental. Then we do this for also or directly to some companies, and I will mention L'Oréal that we have a partnership with. They are really an innovative company. I mean, if you don't know L'Oréal, look at what they are doing. It's a personal opinion that they have like 4,000 researchers, and they have a strategy where they want to source most of their products formulas based on biosourced materials and or the circular economy. So, for example, you have a product, you have some chemicals inside or components, and they want to replace the components that are not biosourced, for example, with other components. And we build a foundation model based on large data set with formulations, their own data, and also scientific publications and so on. And the idea is to equip the plus 4,000 researchers so they can replace the components they are not willing to keep because they are not biosourced or part of the circular economy. Then we speak about what's coming next in computing, and many things will come. I think we are at the beginning of our journey on AI. And part of it is because today we are running on what we call classical computing. We are still innovating in classical computing, and I think it will not be replaced, by the way. It will be complemented by other kind of technologies. And we think that now there is like three computing paradigm in the space. One is AI, of course. I will explain why. And the other one is quantum computing that is coming not so far, because we announced last year that we will announce a quantum advantage by the end of this year. So it's no more science fiction. And the idea is how we reinvent the way we calculate, we compute, to redesign algorithms. And it's not something new for us. We have been working on this since a long time. It's the only mathematical part of this presentation, but I guess it's important to mention. We identified like 4 domains like that are still challenging and part of, let's say, 90% of companies' most important problems. And just to give you an example, a few examples, differential equation and dynamical system. It's something that you can see on the atmospheric modeling or computational fluid dynamics, typically in the automotive space. When we say optimization and combinatorial problems, yes, it's mathematics, but in the real life, it's routing, dispatching, and market analysis. We speak about linear algebra and eigenvalue problems. Yes, still mathematical problems, but when you look a little bit deeper, it's what we call materials and drug design or high energy physics. So when you look at the use case of these mathematical problems, they are all part of one problem in your own company. And the last one is probability, statistics, and stochastic process, so predictive maintenance or energy storage. And the way we do that, I lie, it's the second slide with some mathematics, but the way we do that is we will still continue in the next coming years to use traditional, let's say, algorithms and what we call traditional solvers, but we are working on how to leverage AI to leverage a little bit more, let's say, better the classical computing, but also quantum computing. And so we train foundation model for math modeling, and we also train a foundation model for algorithm design. And one concrete example is one algorithm that we call quantum approximate optimization algorithm. We work with Moderna, and we were able to predict the secondary sequence of mRNA with 60 nucleotides. Not going into the detail, but this is a first of a kind in the world to run such a problem in quantum computing. So that's one example, and we work also with HSBC on the bond markets, where we designed a new method that improved models' ability to predict whether a trade will be executed at the quoted price by up to 34%. So with real data that is in production. So quantum is no more, let's say, something that will come in the next couple of years. Yes, it will, but now we start to see really concrete example, and it's not quantum alone, it's hybrid, it's a mix between classical and quantum computing. And regarding AI, we all have seen how LLMs work. I think work down. Now in 2023, we thought about an LLM as a platform. What it means when you're a company, you want to deploy AI, but you want to deploy AI where you want. It can be in a public cloud, it can be on-prem, or it can be both of them, hybrid, but you decide where you want to deploy AI. Then companies started to look at ROI. And ROI comes with a small model trained on very specific use case with company data, and then you can have something that has a concrete ROI. So I think this is not thinking about models. For us, model will be, and is, a commodity. You will have big models, small models, you will have US models, you will have French models, you will have Spanish models, Japanese models, etc., etc. And what we think is that, you know what, we build a platform, and then if you want to use a Mistral model, you can use a Mistral model. And maybe we did that in Japan, for example, or in Spain, where they developed their own model for Spanish languages and also the regional languages in Spain. So we give the choice. And what is funny about it, I spoke about the clean data, but I will give you a simple example. We train a model of 13 billion parameters. We use like 6.5 gigabytes of teraoctave of data, and we had to delete the 2/3 of this data. Why? Because inside this data, you have license copyright problems. So is the code that you generate is really your code? Are you sure about it? We found like 200,000 books under copyright. We found hate speech, bias, legal concerns, links that are, believe me, problematic, let's say, for a company at least. So that's the kind of problems that when you want to deploy at scale comes into the mind. And then injecting your enterprise data into a model. But what does it mean? It means that when you inject your own data, the data is gold for you. It's your IP, it's your value. So who owns the model? If you inject the model somewhere in a black box, believe me, it will be a problem for you. But if you have a model that you can take and you can deploy where you want, you can tune with your own data, make sure that you own the model. And this is where open source is also very important. And different kinds of open source, because when we say open source, you look at the license and then you can judge. And next, it's the agents. And yes, the agents is a good problem. Now we have chatbots, assistants, agents that does many tasks, and we can handle many kind of data. We have an explosion of developer frameworks and protocols. I will not go into the details, but you see a lot of stuff. And what we see is that AI and software appear to be a little bit in a conflict. Like the software world is like we encapsulate functions and models. We can handle exceptions. We have the portability across architectures and operating systems. And when you look at AI, it's more ad hoc prompt engineering. Nearly all errors are silent and hard to isolate. Limited portability. And when you look also at what we do every day, we do a prompt, larger prompts, even larger prompts, and then page of prompts, book of prompts, tons of prompts. And from an IT perspective, that's not really maintainable. And it's not secure. Simple example, you have a teacher who gave homework to the students, and he gave the homeworks in a Word page, written with the font in black and the background in white, but he inserted inside the text some guidance with white font on the white background, saying if you use generative AI, put these 10 words. And believe, and the result was simple. Almost all the students, the 10 words were present in their homework. And this is a very simple example, but now put this at the company level and the risk that we can have when we have to manage all these prompts. Not portable. What does it mean? If you try, for example, to ask something to a model, then you ask the same thing like 10 minutes later, maybe you will not have the same answer. And even worse, if you use multiple models, you will definitely have not the same answer if you do exactly the same prompt. And from a software perspective, it can be problematic. And we came with this concept of generative computing because we say, but who said that we have to speak in natural language to an AI model? Of course, the end user will keep going and use this, but in the middle of the end user and the model, we will have to implement a runtime where we put some code, and code will discuss with AI and not natural language, which means that if you can put code between the end user and the model, you can put guardrails, you can have your own requirements, you can have your own instructions, your own general strategy, and make sure that the output you are expecting is already there. And by the way, just respecting your company policies, injecting company policies, and so on. Then in semiconductors, we will see a lot of progress. We already see a lot of progress. For example, now you can see chips for inference in AI. So when you deploy AI, they will use this kind of chips to run. By the way, this kind of chips, and we have one, but other companies, they also are developing their own chips to deploy AI in order to consume less energy. The one that you see just on your left side is 8 times less energy, use 8 times less energy consumption, which is for us very important also to improve and already in production. And then we will think about neuromorphic computing, so inspired by the brain. And we published a paper recently where we compared this kind of chips with, let's say, GPUs. And we saw things like 72 times, I'm not percentage, 72 times more efficient in terms of energy, and 47 times more performance. So this is the kind of hardware that will come in the next couple of years, and also the classical hardware will evolve. So the small chip you see on the right side is what we call a 2 nanometer chip, and it's the size is very small, as you can see, but we can put like 50 billion transistors inside. So now the problem for the next generation is 50 billions inside this chip. Now we put them with a 2 nanometers, but now comes the 1 nanometer, and then come the 0 nanometer. You know, so the space is reduced, and we have to innovate a little bit on this. And one way to innovate is to change a couple of things. We use now for communication between transistors copper, by the way, introduced by IBM in 97. And now we'll use different kind of materials, like one, it's called ruthenium. So back to school, but it's one material that will allow us to go a little bit further than the 1 nanometer. And then we will put transistors above each of them. So kind of building the Manhattan of the chip. So now we'll use this kind of architectures, and it will reduce the energy and increase the performance. But many stuff are coming. And last, quantum computing. I say to you that we will announce by the end of the year quantum advantage. When I say a quantum advantage, is we will produce something that is not replicable or doable by a classical computer. Okay, so that will be something new, but we are calling it like the quantum revolution. But clearly, it's not the first quantum revolution. The first quantum revolution appeared hundreds of years ago, and when you look at all the technologies that are coming from quantum mechanics, like the laser, MRI, solar cells, atomic clock, LEDs, polymers, and so on, it's tens of trillions of dollars worth of impact when you look at this. But we believe that quantum computing is the same kind of disruption in terms of technology. And you can see many use cases like developing lighter, longer lasting batteries for electrical vehicles, designing new materials, discovering new class of antibiotics. I mean, use cases now are really increasing and improving. And you can see some words like optimizing, vehicle routing and scheduling. And back to my mathematical problems, in fact, what we are trying to do is to break these kind of challenges we have, because we know that even with classical computing, we will not able to address it. And quantum will be one of the solution. And by 2029, we announced that we will have the fault-tolerant quantum computer. So I think this is very exciting years that are coming. And that's it. Thank you so much, and I hope you had a flavor of what is happening.